Okay, I guess this is part D. So here's a sum of the inverses of all the primes. 2, 3, 5, 7, 11, 13. And I just included 1. But, you know, I didn't need to include 1. And the surprising thing is when I take all the primes, this also adds up to infinity. Only the primes.
But we're taking out a lot of other numbers.
We are taking out a lot of other numbers. So I don't remember the history on this one, on who proved this first. It may have been Euler. Lots of things were Euler. Yeah. But I forget who did it. But or maybe it was pre-Euler. Maybe people realized that this series adds up to infinity. Now this is one where I can't give you a quick little argument on the whiteboard. It's a little bit harder of a proof. Although the proof that at least that I remember for this is actually has some really neat math ideas in it, including ideas from counting. Some things called generating functions. So this understanding why the sum of the inverse primes adds up to infinity is teaches you a lot of math. But see, here's what's neat about this, and this is what somebody pointed out on the blog. A guy named Josh commented on the blog about this. We know the series, when you take away the 9s, is finite. So you get to 1/8 plus 1/10 plus 1/18 plus 1/20 plus, you know, take away the 9. This one's finite. It's less than infinity. So what does that say about the relative number of numbers?
That means
are there more primes, or are there more numbers without 9s?
Well, there would be more primes than more numbers without 9s.
Why?
Because this sum is bigger than this sum. Even though it doesn't really look like it, but it seems like there are.
Yeah.
It's pretty interesting. Pretty interesting. So, and I don't know what it means to be more, because there's infinitely many numbers here and infinitely many numbers here, but there must be a lot of primes.
Yeah.
And we can actually begin to understand this a little bit.
Maybe it's sort of like the 9s, and they get more frequent as you get bigger numbers.
Well, yeah, and that's. I'm glad you mentioned that, because that question about how many primes you get as you get bigger is one that's fascinated people over the years. And even recently there have been big breakthroughs in understanding the number of primes. So let's maybe instead of understanding these two sums, let's talk about primes for a second, okay?
Okay.
All right.